Good morning, everyone. Um, Super happy to be here and super nice to see that I barely know anyone, which is great. No, which is absolutely great because you will see so much data is coming up. I have no idea what you guys are doing today, so I might be repeating some stuff, but we need new people for sure. So I can only single out very few I know here. My name is Zoltan Szantoi. I go as Zolti, so feel free to call me like that. I'm a land application scientist at ESA. As the title suggests, I deal with application-related stuffs. Application in the sense of how to use Earth observation data. And actually within my domain, I deal with mainly with agriculture, where many of you know land surface temperature and evapotranspiration eventually, and all the others will be super important. So let's jump into what I'm not the land surface temperature mission scientist, by the way, so that's someone else. But since I deal, as I just said, with agriculture and land surface temperature data in general, we thought that good if I come, but that most of the slides will be shown from Benjamin Kurtz, who is the mission scientist for LSTM at ESA. But before going to LSTM, two slides about ESA. I'm not going to introduce much, only the really important stuff, the money. So this is the money we are dealing with this year, 2024. By the way, I'm coming from here. 2024, we have around 8 billion. Every 3 years, we have ministerial, where actually they decide, the member states decides our budget. So that's next year, October. So we are all stressed about that. Last year, we asked a certain amount of money and we got more. How much? And not last year, like, 3 years ago. And let's see what happens in October next year. One more slide about ESA or in general. I want to emphasize, of course, this number here, 2.3 million. Sorry, 2.3 billion, right? Yeah. So basically, we spend 30% of ESA's budget on Earth observation. Of course, everything included. So the LSTM mission is included in there. Obviously, my salary is included in there, and all the others. I just wanted to show this pie chart to realize how important we feel to look at the Earth. Of course, ESA is a civilian space agency, so we don't deal with military stuff at all. But still, I mean, you see the other stuff. This is good or bad, you tell me. I'm happy with that budget. So, all right. So we have the Earth observation itself. We already looked at where is going happening, how much money we spend on that, and basically, again, this is our repertoire, if you will. From 2010 all the way, you see it up to 2030 and beyond. And of course, this is more or less where we are now. 4th of December, right? So Sentinel-1C is going up today. Am I correct? Right. If everything is okay, it was supposed to go up on where is Sentinel-1C? Right there. Actually, it's a little bit behind, but anyway, it was going to be up yesterday. I think it's going up today. So let's hope that all will go well. And of course, we are here for some of the others. Especially, we are here for, of course, these ones mainly. And for this particular group, we are here for LSTM. So not only we are looking into from the Earth observation perspective and the next generation of the Sentinel-1-2s, but really these supporting missions which are coming up, which currently we are calling them expansion missions, but actually they will be part of the Copernicus family in general. And you see the ones which we are especially proud of, or because these will be again what we call operational satellites. Of course, all satellites are operational, but as if you remember the previous slide, we had science, which is, it's just kind of, well, operational for sure, but it's only for 3-4 years or 5 years, while these are long-term missions with, with all assurance on quality, data, and so on. So this is where we are. Also, we are already talking about Sentinel-1 next generation, Sentinel-2 next generation. So this you will see in the news, hopefully, and part of the Sentinel-2 next generation mission advisory group. So you are already talking about, okay, spectral bands, revisit times, and all those. Of course, everything boils down to the budget, right? But you know, that's another story. Now, since I have 20 minutes, I'm kind of rushing here, and the ladies are pretty keen on the timing. So we have a land surface temperature monitoring mission. As I said, mission scientist is Benjamin. And this is the one which, well, we are all excited about, but this is really the one what we think in terms of, you know, the pressure on the climate change, agriculture, food security, all those. This will be helping, or these rather, because it's going to be two, right? Will be helping us quite a bit. So just one slide on the climate change impact and the adaptation. What we are looking at, this is coming from IPCC. We have basically, we are looking at 3 or 4 key risks what the LSTM mission eventually can, or the data from there can answer. So heat stress, so basically human related or urban related stuffs, agriculture related stuff, losses in crop production, and coming back to the water cycle kind of. Again, I always connect, obviously, water back to connect water to everything, obviously, but definitely connecting back to agriculture as well. Some of the future applications, but you know, I hope you already talked about EP, you already talked about the LST itself, so land surface temperature, evapotranspiration, super important for agriculture. We have some slides, so we are showing the heat island effects in Milano, but I think I have some other slides for Athens, Madrid, Rome. I mean, in the UK here, I think the heat island might not be that prevalent yet, but it's coming up. So I'm coming from Rome, basically. I can tell you, June and July are kind and August are quite rough there. So the top 10 risks. This is coming from the World Economic Forum, but again, it's kind of repeating what I just said, you know, extreme weather events, critical change in the Earth system, biodiversity loss, you name it. So you can really connect land surface temperature or increasing or decreasing temperature in different parts of the world to all these problems. Now, going to the mission itself, this is the satellite. And it's a beautiful one, right? And to go into details, I jumped to the next slide actually. So we have a key requirements, right? That's what gets formulated when you are starting to talk about a satellite. And basically these are the key requirements for the LSTM. So you see the revisit time, basically the temporal resolution, but then actually the actual revisit time in part of the day, what spatial resolution, channels, and so on. So this is what we are working with currently. Plus, of course, you have the evapotranspiration part, which we focus quite a bit, and naturally the LST part. So for you to really remember, and I don't know the background of almost any of you here, but of course, the very important is basically the first 4, I guess, 4 lines every 2 days, once both satellites are up. 1 o'clock European time, Central Europe, I guess. 50-meter spatial resolution and the channels. Of course, you have all the engineering part and what you have to support with. I talked with Adrian yesterday, and he said that he looked into calibration validation quite a bit, so I'm not going to touch that. And now these are the products we are hoping to get eventually. So we will have level 1 C and level 2A products. Basically, again, this is coming from user consultations and of course what is feasible and possible to get from the data flow, what you hopefully receive. So, and of course, from these data sets, you can still derive additional data sets, obviously. So I think evapotranspiration is not even there. So you know, you get land surface temperature, whatever, and you go further from there, and that's up to you what you do with the data within a proper scientific domain, of course. Acquisition mask, we will see everything as always. I don't know how much you know about the well, political and to suffice political and technical needs, and those are always the small islands. If you work with the Sentinels already, Sentinel-1, Sentinel-2, you might be missing some of these islands. They are not there for various reasons. Anyhow, you see what we will be covering here. This can always change, so many times a member state come to us and it's like, I want that island. And then eventually we go there and we report data over that particular island. So that happened with Sentinel-1, happened with Sentinel-2. Probably will happen with this one as well. Anyway, what you see, it's the globe. So the terrestrial part are quite well covered, especially between 56 and 80 power latitude, major islands over Europe. And I must emphasize that it's not like we are focusing on any particular geographical location or area, but still the main focus will be this line here, Europe and Africa, basically. How we will be connecting or collecting rather. So this is how the two satellites gonna be working. I think I didn't talk about when they go up yet, but I think that's still coming up. So this is what you see. And if we wait enough, but we have only 20 minutes, so we're not gonna wait enough. But believe me, this thing's also gonna be filled up eventually once you are you have a cycle. So this is the data what we're gonna be collecting, and it looks pretty good. And again, the promise is that every 2 days you will have coverage on the same spot on the Earth. Now, of course, I don't really have to go into the cloud cover problem. I think all of you know this will be hitting a little bit the thermal emission or touching the boundaries there. We have to leave with that. But I will have one more slide on that to make you a little bit happier. This is the mission status. Basically, what you have to see is the latest dates, Q4 2024, CDR. It's happening not as we speak, but I think it's still in December. So this is something major, and of course the most important numbers or dates for you guys is this one and that one. So it's not tomorrow. Sorry about that. But today is something I will see. But it's coming. But of course, the good news is, and that's my next slide. We have some. It's not like sister missions, but you know, I guess. I think someone from CNES is listening, right? So I must be nice here. So of course, Trishna is coming up, and yeah, we will hear when exactly, but I think next year Trishna is going up, right? And then SGB, we will have also a talk on that today, I believe. SBG is coming up, and eventually LSTM, A and B are coming up. So look at that globe now. So if you are really digging into land surface temperature or in that domain in general, you will be very happy from the 29 to the 30th day. So hold on or hang on, please. But if you don't want to hold on or hang up, on that, let me see how to go to the next slide. I have a little bit of a pet project, and that's with EcoStress. Everyone knows EcoStress? Oh, good, great. I know you know, I know that, I know that. Great, excellent. So we actually, although we are ESA and EcoStress is NASA, right? It's on the International Space Station. But we put a lot of effort into the EcoStress data, both from the technical or engineering side, but also from the application side, just to dig into what is coming and what we can use the data for. So as you can see, we have a bridge here. So the bridge is trying to show you the spatial resolution and the temporal resolution, what is happening, what is out there already, and where we are going, basically. So we are coming somewhere here. And then, of course, all of this will be somewhere here, right? And what we have currently is basically EcoStress, really, which is also here. So if you really want to already concentrate and work with land surface temperature or evapotranspiration, things like that, then your number one choice is EcoStress. And of course, you can also play with Landsat, and then you have already some data to work with. And what data you have to work with. So then, again, from the EcoStress data, we focus on LST and ET quite a bit, but also GPP eventually. And these are the algorithms we use to derive these data sets. So these are already available. So the project I have is called European EcoStress Hub, so EEH. It's run by LIST, Luxembourg Institute of Science and Technology. And actually, Agnieszka has a little part in there. And we are providing all this data, already some, I think, there on the VAST cloud platform. So feel free to go there, discover it, see what is already there. And what I did not say that EcoStress, of course, is running from 2018, gonna be running to my latest 2026, 2025, something like that.
It's a pending senior review, but 2029 potentially.
Okay, here you go. So the beauty of EcoStress is, apart of all the troubles, and I'm not going into the problems that you have with EcoStress, some of you know that, you will have a hopefully fairly dense time series or data packages from 2018 all the way until Trishna, SGB, LSTM are kicking in. And still, it will be complementary. So look at this data. Within the European EcoStress Hub, we are focusing, as the name suggests, on Europe, but not only. We also have Africa data sets. So these are all available, and the project will run until 2025 or 2026. So we will eventually have a full archive of land surface temperature and evapotranspiration from 2018 until 2025 within the EEH. And this is just, I don't think I have too much time, so this is just an example from the EEH data, what we derived. So this is mapping urban heat islands. And the usual suspects, Rome, Madrid, even Paris pops up. And then, of course, looking at water stress. So these are already projects what we conducted or collaborated using the EcoStress data for different works. And I took advantage that I'm coming, and I know you guys are LSTM, but if you remember, I showed what else is coming up. So I thought to put 2 extra slides on this. So Rose-L is coming up, which will be on L-band radar. We will not spend much time on it, but all these are coming up more or less at the same time. I think Rose-L might be in 2028. I don't know if I say it somewhere on the slide. Yeah, no, same time as LSTM. So Rose-L is coming up, and Chime is coming up. All more or less around the same time. You will have a lot of data. And I put these 2 up as well, not to bore you, but because if or at least from my domain, from the agricultural perspective, these are super, super important. Rosal, different wavelength radar. You can pick up different stuff, of course, compared to C. And chime hyperspectral, I don't go into the details, but it's very detailed, right? So a lot more detailed data than what you will get, although with a little lower spatial resolution than the Sentinels. And basically, I don't know, what's your timing? I'm okay. So this is my official last slide, but then if I have time, I might want to say two more words, or two more slides. All of you are coming, right? Good, good. I think the deadline was yesterday, so sorry about that, but you email me if you still have some mess with the submissions, okay? But yes, please come. I think I can say that, and we all can be very proud. It's the #1 Earth observation conference in the world, so come. I always have fun there. Last one was in Bonn. Everyone got COVID, so that was awesome. But then let's see what happens in Vienna now. Okay, so this was my last slide because the ladies here are very strict on the 20 minutes. But I want to show this thing. So as I said, at ESA we put a lot of emphasis on looking at what is coming up and how, for my case, for the better good, for social benefits, but also from the company perspective or business perspective, how you can use that data. So we had a call out recently. Again, I don't know where you are coming from. You might be one of those who are participating in one of these projects. Point is that we had something called Sentinel User Preparation. So this is from EOP, Earth Observation Program Directorate, that's what I am. So we had this call for proposals, we call them ITTs, invitation to tenders, where we ask our member state companies, universities, research centers to come up with proposals to use live data, how chime will gonna look like, how LSTM gonna look like, or how, whatever, any of those which are coming up, and you see other ones, right? Not only those three what are focused on now. So we had this call out, overwhelming response. Let's see. So basically, this was the details. So these are all the satellites or all the data flows what we were interested in. This was the call. So basically, we had 15 million euro on that. And what we did, we awarded whatever, I think 18 or 19 projects eventually, could be even 20. More or less 800K each, I'm talking about in euros, contract on this project. Now, I had a bunch of projects, but I'm not going to go into that. So we have already, some of the projects already kicked in. I have one, obviously on LSTM related stuffs, which we will be kicking in January, if I remember correctly. And I think I stopped here because of the time. But anyhow, so this is what we focused on agriculture, talking to back home, sorry about that. So we got a bunch of proposals on LSTM, chime, and Rosa, how to use them together. And really the last slide. So this is basically, I thought, to be interesting for you guys here. So out of all the proposals, which I am not entitled to say how many we got, but we found 20, so you can imagine. What was the main interest in those proposals? And you guys are all LSTM people here. And look at that number. So it's pretty amazing, the interest behind LSTM. So we are extremely pleased with that. And of course, rightly so, chime, the hyperspectral mission, which was also quite popular. What's the other side? And this is the applications, yes. So looking back home again, I am in field A. So 17% of the proposals were going into basically the agriculture domain. So, but I don't know. I guess any of you can pick some of those that you are interested in. Point is, super high interest behind LSTM or generally in thermal data. So I think you are in a really good spot to do this. And I thank Jennifer and Agnieszka for doing this. Thank you.
Great. Thank you, Zoltan, for the amazing talk and all the highlights about subjects and future missions. Because fusion of the data and missions is becoming increasingly popular and increasingly important. Are there any questions to Zoltan? Yes, there are. I don't know who was first.
Oh, no, no.
First. So, but no.
I hear you. Okay.
Check. Yeah. You told that one overpass will be at 13 o'clock, like Central European time, and you also mentioned the night observation.
I was with the Central European time. It's gonna be
L10, exactly. I was just about to ask that it's a sun synchronous orbit, anyways, right? Yeah. And what do you mean by night observations? What do you mean by night observations? You mentioned 13 o'clock and night observations. What?
I don't know, but there will be night observations. I assume then the one is passing through that will be on daylight, and the other one is passing through nighttime.
Okay.
So we'll be collecting the data. Honestly, again, I'm not really dealing with those stuff, so honestly, I don't know. Sorry about that.
Yeah. Thanks.
Yeah, it should be. I assume, yeah.
I have a question about the resolution of the visible and near-infrared channels. You said that you're also including, which I presume covers the full swath. So what is the spatial resolution or GST of those?
It's supposed to be 50 meters, so we are shooting for 50 meters. And my understanding from the mission scientists that this is pretty much covered.
And is there any coincidence at all with Sentinel-2?
Coincidence in what sense?
Spatio-temporal coincidence?
As you know, it's 10 meters, right? So in that sense, not really. The new, by the time when LSTM gonna be up and Sentinel-2, we are already almost talking about the next generation of Sentinel. And what I can tell you is we are at 5 meters in the discussions now. It will be even higher eventually. So if you look at 5 meters to 50, you have a multiplier there, but in that sense, not we will be using LSTM data, of course, for cloud screening and all those for the Sentinel-2 data, right? But that's kind of considered in.
So they will be synchronous, taken at the same time over Europe and Africa.
No, they will not.
Okay.
No, it's just that Copernicus, for example, the Global Land Monitoring Service, which I'm heavily involved in, they have lots and lots of downstream products like albedo that would be great to be able to do direct comparisons with ET, but that requires it at the same time.
Yeah, Sentinel-2 will still be a morning acquisition and LSTM early afternoon. So not strictly at the same time.
Yeah, thank you.
But same tiling system, so that it will be the Sentinel-2 grid that will be used for all of these products. So still to be easy to use together. Sorry for.
but if it's not the same time, how can you do anything?
I mean, albedo is quite stable, so you can still work on data that are not acquired at the same time.
Okay.
So if the overpass is in the same day, of course, for the cloud, you can still kind of use it, right? But again, you are obviously not at the same time, so you have to consider everything. But that's why we have some people looking into these issues. Any other questions?
Does LSTM provide direct broadcast capabilities?
in real time or?
Yeah, I mean, like can any user download the data directly from the satellite when we have a ground station?
Directly from the satellite?
Yeah.
No, I think it's going to be from the ground stations, but the latency will be, I think I have some numbers in the latency is like, for level 1C product is like 3 hours, level 2A product I think was 6 hours, somewhere there is in the slides.
Okay, thanks.